Hello everyone, this is Shankar, faculty for Power Electronics and Control Systems at OHM Institute. In this video, I would like to discuss control systems questions given in recently conducted exam TSSPDCL Assistant Engineer paper. This exam conducted on 30th April 2023. Now let us go into the questions. Now the first question from control systems. There are 4 statements are given. Out of these 4 statements, the question is to identify the correct statement from this given 4 options. So basically just by seeing these 4 options, it is mostly the properties of PI and PD controllers. Okay. So now let us read the first 2 statements. PD controller increases the damping ratio and peak overshoot of the system. So straight away I can reject this option. Why? Because damping ratio and peak overshoot both are inversely related terms. That means if damping ratio increases, then percentage of overshoot decreases. Therefore, that statement is given that PD controller increases both. That is not true. And second statement, same PD controller decreases both, because both are inversely related terms, you can simply reject it. The next one is PI controller increases the order of the system by 1. This is correct. So why? Because in a simple cross checking is, say for example, let us say some control system, a unity feedback system, there is a controller here, that is a PI controller. Now let us take a first order system here, K divided by S plus 1. Okay. So this is a unity feedback system. Now this is a first order system. For this, if we employ PI controller, okay, so let us take a simply integral controller, same concept is applicable for PI also. Therefore, for this control system, if you take the closed loop transfer function, straight away it is a second order system. Okay. Therefore, first order original plant, now overall system becomes second order. PI controller increases the order of the system by 1. So this statement is true. So for this question, option C will be the correct answer. And PI controller becomes more stable than the original one. The problem with PI controller will be, say for example, if root locus is in the left side, by employing this PI controller, the more tendency will be the root locus diagram will shift towards the right hand side of the S-plane. Therefore, stability point of view, PI controller is not having superior characteristics. So for this question, option C will be the correct answer. Now let us move to the next question. Now in this question, a 3 by 3 system matrix is given. For this system matrix, you need to find out what is the state transition matrix. Okay. So generally I used to explain in the classes also, we need to prepare a little bit of one step ahead. Okay. So this is a 3 by 3 matrix is given. Of course it is not so difficult question, but if you understand the properties of that, then it is very easy to answer this question. Now what is the definition for state transition matrix? State transition matrix normally denoted with phi of t. This is inverse Laplace transform of Si minus A inverse. Therefore, the first basic requirement to solve this problem is we need to have Si minus A inverse. Suppose if I take Si minus A, okay, so what we will get here, S minus 1 is the one element, 0, 0, 0, next element is S minus 2 and 0, 0, 0 and S minus 3. Okay. So basically this is a diagonal matrix, means all diagonal elements are finite values, rest of the elements are zeros. Now if you look into the property of diagonal element matrix inverse, so what you have to do, you need to take inverse of each diagonal element. Okay, that is 1 by S minus 1, 0, 0, 0, 1 by S minus 2, 0, 0, 0, 1 by S minus 3. Okay, so this is a Si minus A inverse matrix. Now we want state transition matrix. The definition is inverse Laplace transform for this one. Okay, so inverse Laplace transform for Si minus A inverse. Therefore for each element, if you take inverse Laplace transform, what you will get? Inverse Laplace transform for 1 by S minus 1, it will give you e power t, remaining elements 0 here, 0, inverse Laplace transform of 1 by S minus 2, that is e power 2t, and this is 0, 0, 0, e power 3t. Therefore for this question option C will be the correct one. Now let us look into the next question. The number of forward paths and all possible combinations of two non-touching loops of the following signal flow graph. Now first let us try to identify forward paths. Forward paths. Okay, now the first path will be, let me write with M1 is equal to G1, G2, G3, G4 and 1. Okay, so that means you need to start from the input node and you need to reach to the destination node, that is output node, and in that process each node you should touch only once. Okay, next M2, that is G1, G6, G4. Third forward path will be G1, G2, now G7. Okay, that's all. So these are the possible forward paths. Therefore there are three forward paths in the given question. Now let us look into loops. First let us write down the individual loops. Let me call it L11. Okay, so what is one loop here? G2, G7 and minus H2. Let me show with another color here, this one. This is one loop. Okay. Now another loop is let us use symbol L12 is G4 minus H1. Okay, so these are the two individual loops. Of course these two loops, individual loops, are not having any common node. Therefore these two itself one combination of two non-touching loops. Therefore finally I can select the answer. There are three forward paths and one combination of two non-touching loops, that is option A will be the appropriate answer here. So in this one there are two non-touching loops, there are two loops, these two are non-touching, and combination wise it is one combination of two non-touching loops, and hence I am selecting option A. Now this is one of the I feel some of the lengthy question. It will take more time but not so difficult. The steady state error for unit step input of the following system represented by state space form. So generally we will study the error concept in the time response analysis, and of course the system transfer function you can find from this one, and then you can find out the error. Okay. Now let us say a few basic definitions here. Closed loop transfer function T of S is equal to C of S divided by R of S. This can be written as C multiplied with Si minus A inverse into B. This is a closed loop transfer function matrix. What is error function? E of S is equal to R of S minus C of S, R of S minus C of S. Okay. This can also written as R of S minus R of S into C multiplied with Si minus A inverse into B. C multiplied with Si minus A inverse into B. Therefore, if I take here error definition, R of S, if I take it common, 1 minus C into Si minus A inverse into B. Now what is the steady state error with respect to unit step function? Limit S tends to 0, S into E of S. Okay. Therefore, limit S tends to 0, S multiplied with what is given in the question? Unit step function. R of S is equal to 1 by S into C multiplied with Si minus A inverse into B. Okay. So here you can cancel this S and S. So finally we are at a stage like steady state error is equal to limit S tends to 0, C into Si minus A inverse B, right. So you have to evaluate this limit. Now let us see that one. Let me take this picture once again just for the reference. So first let us calculate Si minus A matrix. So what is that? S 0 0 S minus 0 1 minus 4 minus 2. This will give you S minus 1 4 S plus 2. Okay. The next step, Si minus A inverse is equal to 1 by S square plus 2S plus 4. This is a determinant. Adjoint S plus 2 1 minus 4 and S. This is Si minus A inverse matrix. Now let us multiply this one, C into Si minus A inverse into B. So what is the C matrix here? Row matrix 1 and 0. Si minus A inverse S plus 2 1 minus 4 S, and B matrix 0 and 1. Okay. Now denominator S square plus 2S plus 4. Now let us multiply this one, 1 0, and here 0 into 1, it will give you 1, 0 into 0 plus 1, that is yes, 0 plus S into 1, that will be yes. Denominator S square plus 2S plus 4. Okay. Therefore, it will give you 1 divided by S square plus 2S plus 4, right. So, this is C into Si minus A inverse into B. Now, if you go back to the previous one, this previous one, now here there is a small correction. So, what is that correction here? Let me do this one. So, basically here you will have when you take this common, so basically this is a 1 minus, I am sorry, 1 minus C into Si minus A inverse into B, right. Now, if you evaluate this limit, what you will get here, steady state error is equal to limit S tends to 0, 1 minus C into this matrix, so 1 by S square plus 2S plus 4, then it will give you limit S tends to 0, S square plus 2S plus 3 divided by S square plus 2S plus 4. By substituting S is equal to 0, the finally this value will be arrived to 3 by 4. 3 by 4 means 0.75, and hence option D will be the correct answer. Now, let us look into the next question. The value of gain at the breakaway point of the root locus of a feedback system whose open loop transfer function is given by GH is equal to K by S into S plus 1. So, this is another very small question. So, K by S into S plus 1. So, for this open loop transfer function, if you look into the root locus diagram, it will be like this. So, there is a pole at the origin and pole at minus 1. When gain K is increasing from 0 to infinity, what happens to this root locus diagram? These two poles will move towards each other and breaks away at a one point. After then, it will depart into the complex plane. Now, here the question is, what is the gain value K at this breakaway point? So, you have to calculate what is K value at that breakaway point. Straight away, you can easily answer that the roots of the two characteristic equation are located on a real axis. Therefore, from the given system transfer function, if you find the characteristic equation, you will have S square plus S plus K is equal to 0. And what are the roots of this characteristic equation? S1 comma 2 is equal to minus 1 plus or minus B square, that is 1 minus 4AC 4K divided by 2. So, for the roots of the characteristic equation to be located on the real axis and both are equal, this imaginary part, this term has to be 0. Okay. Therefore, when it will enter into the complex plane, whenever this imaginary number, say for example, if I write like this, minus 1 plus or minus j root of 4k minus 1 divided by 2. So whenever this complex number imaginary part is 0, at that point the roots are both are located at a same point. Therefore for that the condition will be 4k is equal to 1 or k is equal to 1 by 4. So for this question we can select the answer is 0.25. Now identify the correct answer from the following statements with respect to Nyquist contour. So if you simply look into the Nyquist contour, this is a real axis, this is imaginary axis. So what is the Nyquist contour? It will be along with the y axis and an infinite semicircle a semicircle with an infinite radius. Okay, therefore the along with the imaginary axis the frequency is varying from minus infinity to plus infinity. So the yellow color part will be the Nyquist contour. Now let us see here what are the answers. It consists of the entire j omega axis, that is true, and a semicircle of finite radius. This is wrong, infinite radius. Second option, it consists of the entire j omega axis and a semicircle of infinite radius. It is okay. Now the option C, it encloses the entire right half of S plane. It is okay, but it is traversed in the counterclockwise direction. This is also wrong. On the j omega axis, omega varies from 0 to infinity. This is also wrong, minus infinity to plus infinity. Therefore option B we can select as an appropriate answer. Okay. It consists of the entire j omega axis and a semicircle of infinite radius that should cover the entire right hand side of the S plane. So basically this selection criteria is due to check whether any right hand side closed loop roots are present or not, to comment about the stability of the system. So for this question I can select option B as the correct answer. Now let us see here. One matching is given. This question is based on the Bode plot, phase diagram, phase plot. Now by seeing the matching left side and right side, a pole and two poles or 0 and 2 zeros at the origin. So what will be the corresponding phase angles are here. Pole at the origin, it will give minus 90 degree, the phase plot. Two poles at the origin, it will have minus 180 degree. Okay, so BS. 0 at the origin, it will have 90 degree, 0 at the origin. Two zeros at the origin, it is 180 degree. Therefore option A will be the correct answer. Now here the next question. Choose the correctness of assertion and reason statements. Zero input stability is called the asymptotic stability. Okay, therefore I can this is basic definition. So this statement is this statement is true. This statement is true. So A is true. Now in the absence of any input the output tends to finite irrespective of the initial conditions. So basically the control systems deals with the causal systems. Whenever there is no input, means when there is input is not given, so the output is a finite to me irrespective of the initial condition. If any initial condition is given then it is okay, but when there is no initial condition, is irrespective of the initial condition. Say for example initial condition is 0, the output has to tends to 0. So in the absence of any input the output tends to finite irrespective of the any initial condition. In my opinion this is not correct. Therefore A is true and B is not correct. Okay, B is not true, that will be the option. Now by seeing these control system questions, my view on these subject control system questions in this paper, only this question is a little bit lengthy and the rest of the problems are not so lengthy. Control system, the difficulty level in my opinion I can say easy to moderate. but from the overall paper perspective and based on the feedback received from my colleague faculties also, in each subject some questions are difficult and most of the questions are easy to moderate. Okay, therefore the overall paper from of course we need to check with every subject also. To be from power electronics and control systems, power electronics is moderate to tough, control systems easy to moderate. Okay, so with this I will conclude this video. Thank you for watching.